Hello, and hello to you, the moon.
And the moon.
We're going to learn all about you today, moon, and in this video we are going to look at a few bits and pieces all to do with you. We're going to see how you are responsible for what we call months here on Earth. We are also going to look at your phases, and these two are quite closely related. We're going to think carefully about how you orbit the Earth. I'm going to spell orbit correctly. How do you orbit the Earth, moon? And we're then going to draw on your orbital patterns to have a look at eclipses. So that is the plan. And just to note, this is a picture of the moon, and this was taken from Earth with the aid of a telescope, and this is a red moon.
The red moon.
It's obvious, but this isn't a fake photograph. This is a real photograph taken of the moon during an eclipse when it went red, and we're going to try and work out why on earth would a moon go red. Okay, so what is going on here? This is our planet Earth, and this is the sun. And we've already discussed in previous videos, and you're happy with now, the idea that the Earth is on an orbit around the sun. So we've got here this large orbit here. It's going to go around in a really big circle, massive orbit all around there. But what we've also got going on is that our moon orbits the Earth like this, and it orbits the Earth. Okay, so we've got a big sun and the Earth orbiting it, and we've got the little moon orbiting the planet. Sometimes we see our moon differently. Occasionally, or we'll see this full moon, we see the whole thing, and you see a big bright moon in the sky. Sometimes you won't see a moon at all, which is quite sad. Sometimes you can't spot the moon in the sky, and at other points there's varying degrees of illumination of the moon. We get crescents, we call this quarters, and these are gibbous, the waxing and the waning gibbous, and this is all to do with the position of the moon relative to the sun. When do we get a full moon, I hear you ask? If the moon is on this side of the Earth, if the moon is over here, come on, let's get coloured in. If the moon is over here, then all of the light from the sun, or loads of light from the sun, can freely travel from this direction, hit the moon, bounce off the moon, and on Earth at night, so on this side of the moon, on this side of the Earth over here, during the night time, we can see the moon. And as you can see here, all of the moon is lit up. So this part of the moon, all on this side, it's all lit up. So that every bit of the moon that's facing the sun gets lit up. Half of the moon is in darkness, the dark side of the moon. But we can't see that anyway. From Earth, what we see when we're looking up at the moon is a full moon. We see the whole thing, and it appears to us to be a giant circle. So because half of it is illuminated, and a full half of it is illuminated, looking at it from the side like we do on Earth, we see a full moon. Now, when the moon is in a different position, because we've said already that it orbits, but what about, let's imagine the situation when our moon is over here. So at some other point we might have a moon this way. It's still in the light of the sun. The sun is still shining light onto our moon from all points, and this time this part of the moon is lit up. So the moon is still having light shone on it by the sun, but none of that light is visible from Earth. It is not reflecting back to Earth. All we can see from Earth is, well, we can't see it because there's no light being reflected on it. So the effect from Earth is that we have this new moon, or this full moon. We might still be able to see its position in the sky. We might be able to work out where its shadow is, but we cannot see it at this time because it's not getting its light reflected onto us. Now, at various different points, we'll see different things. What about when the moon is in this sort of position relative to the Earth and Sun? Well, from here, we've still got the sun shining lots of light on it, and it's going to light up. Oops. It's going to light up the side of the moon that is facing the sun here. So all this is lit up. But what does that look like from the Earth? So if you imagine a pair of eyes, someone with a pair of eyes, drawing them in on black there is a bit silly. Nice green pair of eyes on Earth, looking up at here. What do we see when we look this way? We see a half moon. Half of the moon, this side, is in shadow. Half of the moon is illuminated. So from Earth, that looks like this. We actually see a half moon. And from Earth, this moon looks like it is full. Doesn't look green, it's just the colour I'm using. And from the other side of the moon, we can't see it. We can maybe see its shadow, but we can't actually see a full moon there at all. So the shape of the moon, as seen from Earth, as viewed from Earth, varies as the moon orbits planet Earth. And a month is defined relative to the moon because it takes 28 days for the moon to go through this cycle around the Earth. So at different stages and different phases, we have a different conception, a different view of the moon from Earth. So the month starts here with the new moon, and during the course of the month, the way that we see it varies according to how much light is being reflected from the source, which is the sun, by the moon onto planet Earth. It's very important, and I think this is clear, but it's very important to note here, the moon does not produce its own light. It's merely reflecting the light from the sun. It's a moony mirror, or just a moon mirror. It reflects light from the sun, and that light comes back down to us on Earth. And depending on the angles in between the sun and the moon and the Earth, that depends on how it appears to us down here on planet Earth. Okay, so we're now going to have a look at eclipses, and there's two types of eclipses that we're going to have a look at here. One is called a solar eclipse, and the other is a lunar eclipse, but they both involve the sun and the moon and our little planet and the way that they interact. So here we are, sun, moon, earth. Now this important thing to note here is that the sun is constantly shining light on Earth, and it shines a lot of light on Earth, and it's huge compared to the Earth. And I want this line to be yellow, so I'm going to do that again with a yellow line. Oops. So there's light from the Earth shining, oh sorry, sun shining there, and there is light from the sun shining here. Okay. All right. So we've got our situation here. This is the sun. This is the area of light. All this area I tried to draw before is going to be receiving the full amount of the sun's light from here. But we're going to have a couple of areas here where it's sort of partial shadow, because the light from the bottom part of the sun can't get there. The light from the top part of the sun can still get there. So this area does get some light from the top of the sun, but it doesn't get the light from the bottom because the Earth's sort of partially shadowing. Same occurs here, area of partial shadow from the Earth and the sun. So first thing we need, we've got a couple of terms we're going to define. We've got an area of partial shadow, and this is called penumbra, here and here. So because some of the light from the sun is unable to get to these areas, they're called penumbra. This area here, which is total shadow, and this is called umbra. So this is partial, is the penumbra, and total shadow is the umbra. Now what can happen is that our tiny little moon, and you'll have noticed I've shrunken the moon to try to make it a more accurate scale, on its journey around here there are times when it may end up leaving behind an orange bit of space. Let's put that orange bit of space away. No one wants to see that. I don't know why that's happened. Let's fill in the orange bit of space. Ooh. Technical error. There you go, naughty space. And here, the moon enters this area. If it enters this region, then none of the light from the sun is hitting the moon. This is a lunar eclipse where the light of the sun is unable to strike the moon. We can also get a situation occurring, and this is much more rare, but we can get an event happening where the moon fills in the position on this side of the Earth in such a way that it blocks out a section of light from the sun. Now let's see if we can get this to work. Okay, so I accidentally deleted the sun, don't want that. Let's get ourselves a nice sun again. So here's my sun, and when the moon occupies this space, what could happen is that there's a region. Now the problem here is that this is not to scale at all. The sun would actually be many times bigger and much farther away, but I'm going to just cheat a little bit and just to show you the main idea here. We get a region behind the moon where no light can get to, and this region here, in this space here behind the moon and between the Earth, this section of land here, the moon could block the sun, and you'd call this a total solar eclipse. And this is where the position of the moon blocks the light from the sun so that you are unable to see the sun. Now again, there's a region of the moon as well will have a region of umbra. This is in the middle. We can call this the umbra. let's try that again. Umbra. So this is a region of total shadow from the moon, but to the sides of it, do this in a pinky sort of colour, you might get some regions with partial shadow. So here you wouldn't have a total solar eclipse, you'd have a partial solar eclipse, and these would be the regions of umbra, where some of the light is blocked out by the moon. So where is the moon relative to the Earth and relative to the Sun? When it is in the way of the light of the Sun, we get a lunar eclipse, and when it is round the other side, we can get, oh sorry, said that the wrong way. When the moon is blocking the Sun, we get what is known as a solar eclipse, and when the Earth is blocking the moon, we get what is known as a lunar eclipse. Okay, so just to make sure this is crystal clear, I've got a couple of other diagrams. So I tried drawing my diagrams whilst I was going along to show those, but I'll show a couple more just to help to consolidate these ideas. Again, we've got our Sun, Moon, Earth system here, and this situation here causes a solar eclipse when the moon blocks the light from the sun, and this situation here is a lunar eclipse where the moon fits perfectly into the shadow from the Earth. Now, this one, the reason it's called a solar eclipse is because it blocks the view of the sun, so you cannot see the sun. So you can't see what? You can't see the sun, it's a solar eclipse. Here, can't see what? Can't see the moon, it's a lunar eclipse. Why can't you see it? Because it's in the Earth's shadow, there's no light from the sun hitting it to bounce back to us on Earth. So that's the reason, that's a good way to remember it. Have a look at this, have a look at the size of the Earth's shadow here. Big shadow. Have a look at this little one here. Small shadow. These are much more common. There's more chance of this happening, of this alignment matching up, than this one. Solar eclipses are very rare because the geometry has to be exactly precise and it has to fit into place perfectly for this to happen. It's far more likely to see this effect. Again, a couple more pictures just to help us to understand the geometry of this situation. Solar eclipse, sun shines light onto the moon blocks that light from reaching the Earth, so somewhere on Earth you are unable to see the sun. You cannot see the sun, solar eclipse. Lunar eclipse, some parts of the Earth, or some part of the moon's orbit, the moon ends up in this shadow area where light from the sun cannot reach the moon, and so we cannot see the moon. So why doesn't this happen all the time? From this picture, when we've got this circular orbit here, you'd think, or I would think, it should be quite frequent, because, you know, as it moves around, wouldn't you get this once, twice, once, again, every time it goes around? Well, you could be forgiven for thinking this, but what actually happens is that the Earth is not orbiting in the same plane that the moon is orbiting the Earth. So they're sort of tilting out of kilter with one another. So you sometimes might find the moon, yes, it's on this side of the Earth here, but it's not directly blocking the two. And on this side, it's on the other side away from the sun, but it's not in the area of shadow. It's only when the two line up perfectly. So that's why it's fairly infrequent, because not only does it have to be on the right side of the Earth at the right time, it's got to be in the right tilt at the right position. So they're not as common occurrences as you might have thought. A couple of other features of, well, let's just have a look actually. I'm going to show you a couple of pictures of, this is a solar eclipse, and this is taken, a series of photos taken over time which show the path of the moon going across the sun. So here's the sun, and the moon here is encroaching upon the sun and putting a shadow across it. So this might have been 11 o'clock in the morning, 11:05, 11:10. The moon is moving across the sky until it gets to this point where it blocks out the sun completely, and then as time moves on, so if this was 11:15, 11:20, it'd be 11:25, and it moves across, and the moon continues to move until it's out of view, and then you get the full sun uncovered again. Alright, now, so this shows this slide here in the middle, this picture in the middle, is when the moon is bang smack directly in the way of the sun. But you'll see there's some light still getting through, there's some visible light there. So astronomers like to study this situation because it gives them a unique view of something around the sun, which is called the solar, which comes from the Latin for the sun, corona, which means crown, again from the Latin. So this is the sun's crown, the solar crown, and this is a 1.5 billion degree plasma with all material from the sun, charged particles being jettisoned out. And through studying events like this, we came to realise that the sun isn't a perfectly spherical ball of gas. It actually has a sort of hazy edge, and it spreads itself out into space here in this way. And hitting you with quite a lot of information here is that sometimes you get an occurrence called an annular eclipse. Now here we'll notice a difference in this situation where the moon perfectly covers up the sun to this situation where the moon does not perfectly cover the sun. This is because the distances between the sun, moon and earth are not constant. Sometimes the moon is slightly closer than normal. Sometimes the earth is slightly closer to the sun than normal. Those distances are not constant, so sometimes this geometry does not match up. Sorry about that noise, that's my phone. Sometimes this geometry does not match up. Sometimes they do not cover each other perfectly. It's a real coincidence that it happens at all. It just happens that the moon is much smaller than the sun, but the moon, oops, that's not how you spell moon. The distance to the moon is also much smaller than the distance to the sun, and it's just a sheer fluke that they happen to be in proportion to each other, the distance of the moon to the sun and the size of the moon to the sun. So they appear to be the same size in the sky. They look like they're the same size, but they're not. They're not at all the same size. The sun is thousands of times bigger, but also thousands of times further away. But if there's any slight difference, a slight deviation in the distance of the moon to the sun, it can have quite a significant impact on your eclipse. It can also affect things like the temperature on Earth and the tides on Earth. But we get this annular effect where we see a circle here. We do see a circle of the moon. That brings us back to our red moon situation, and this red moon occurs during one of our lunar eclipses. Now the reason for this is a little complicated. We'll later in this module study something to do with this, but what basically it's to do with is when light from this part bends around the Earth. We're going to look at the curvature of light later and how it can affect colours. But basically what happens is that light bends around the Earth and it takes on a red colour. So the red parts of the light are able to hit the Earth, but the blue, yellow, green, other parts of the electromagnetic spectrum miss the Earth, and so it doesn't look like white light. It doesn't have all the elements of the light, it only gets the red bit. But like I said, we'll discuss this again at a later date.
Now it's time for our wrap-up. Let's give it everything we've got. Ready? Begin.
Let's wrap it up. What causes the months? What causes the phase of the moon? Well, it's all to do with the position of the moon relative to the Earth. When the moon is on one side of the moon, here, the far or further away from the sun, it gets the full light, which reflects back onto Earth. When the moon is over here and all the light from the sun is only shining on the side that's facing away from the Earth, we can't see it. So the phases of the moon are caused by where the moon is relative to the sun and Earth, and this pattern repeats itself over the course of a month. We've looked at the moon orbiting the Earth and how these two are related to each other. We've also looked at our eclipses. We've seen that a red moon occurs in a lunar eclipse, and we get a solar eclipse happening when the moon blocks the sun. And that is the moon. I've just want to pay a little dedication to the moon now, and at the end of this video we've just got a few songs that pay homage to the lovely moon.
I stand at your gate, and the song that I sing is of moonlight. I miss the moon.
Well, it's a marvelous night for a moon dance.
Now, we've talked about the moon, we've sung about the moon, we've even talked about the moon being made of green cheese.
And the moon